Okay, so this is your practice form K. Each pair of polygons is congruent, and you got to find your measures of your numbered angles. So angle L corresponds to angle P based on the orientation, and you know the box is 90, so angle 1 is 90. And angle 2 is 40. Okay, so on that one we just got 90 for angle 1 and 40 for angle 2. Okay, on this one, again, they're oriented kind of where it's easy to figure out. So angle 1 would be 95 because B and G to go together. And angle 2 is 60. So 95 and 60. Now on these, some of them in the box are, well, the boxes are too small, so I'm going to put it outside the box. The first one says complete the congruent statement, and you have A, B, which are the first two. So I'm going to put a little 1 and 2 here. That'll help you remember to do the 1 and 2 here. So that's the X, Y. So you put X, Y with a bar. Also, here's the picture of it, so you know that A, I did this one year with circling it. A and X go together, and B and Y go together. And then the one I didn't circle or mark goes together. That's one way to remember them. You know, if you want to do it that way, completely up to you. Or you could just know that A, B are the first two, so X, Y is it. Okay, and this says to start, make sure you know that A corresponds to X. So I'll just put X in the box in that one, and B corresponds to Y. So that's how come we got X, Y. The next one is ZY, and so that'd be like 3, 2 in this case. Let me do this again. 1, 2, 3, 1, 2, 3. So you know that the 3 for Z and then the 2 for Y, so that means it's going to be CB. So CB with the bar. And then number 5, Z, again was a 3, so it's C. So angle C. And number 6, BAC, so that'd be 2, 1, 3. So 2, 1, 3 on the other one is YXZ. So angle YXZ. So again, the whole point of this lesson is to know what corresponds to each other. So for the most part, I just use the numbering system, but if you'd rather do it a different way, you can. The next one is angle B, and so that's the second one, so then that's angle Y. All right, on this next one, they used words for equal many, but it's a quadrilateral, FOUR and MANY. So your 4 pairs of congruent angles would work like this, where it's like 1, 2, 3, 4 to 1, 2, 3, 4. So we have angle F congruent to angle M. So that's your first one. And then angle O congruent to angle A. And then for the third one, you got U and N that go together. Angle U congruent to angle N. And then you have R and Y that go together. Angle R congruent to angle Y. Okay, so we were supposed to get 4 pairs, and 1, 2, 3, 4, yes, we did it. So if it's a triangle, you have 3 pairs. If it's a pentagon, you have 5. If it's a hexagon, you have 6. Any questions? Okay, now this one, don't get sidetracked by this on the congruent sides. It's just the first 2 letters. So you've got this congruent to MA. So your first 2 to your first 2, and then you want your middle 2, so OU. And that goes to AN. So we had our first 2 to our first 2, and then we had our middle 2 to our middle 2. Now we need the last 2, so that's the UR to the NY. So that would have just been 3 sides, and so now we need the, either call it FR or RY, it doesn't matter. Since I'm going to call it FR, then I need to call it MY. So FR and MY. So those would be our 4 sets of sides. Okay, for our next one it says, for the exercises 10 and 11, can you conclude they're congruent and to justify it? So don't just put yes or no. You need to show some work with it. So for this one, what we know is that angle T, well, for figuring out if something's congruent for this lesson, we have to use our definition. And so it'd have to do with 3 sets of angles. And we'll check that, and then we'll have to do 3 sets of sides. So for our 3 sets of angles, we'd have T and Q, which are equal. And we also know the vertical angles are equal. So that'd be TRS with QRP. That's because vertical angles are equal. So we've got 2 sets of angles. And also, if you remember, on this lesson, we introduced the third angles theorem, which means if these 2 angles in a triangle are equal to these 2 angles in the triangle, then your third angles are equal. So S is equal to P from your third angles theorem. And I'm abbreviating third angle theorem. So based on all that, we're good because we have 3 sets of angles which we know about. Now the next thing is, do we have 3 sets of sides? That are congruent and marked that way? And unfortunately we don't, because there's no markings for these 2 or those 2 or those 2. There's no numbers, and so there's basically none. So this answer after everything is going to be no. So you do have enough information about the angles, but you don't have enough information about the sides. So then it's got to ultimately be none, or no. It's got to be no. Any questions? Okay, this one, let's start with talking about our 3 sets of angles. So we know that B and G go together and they have 1 mark. and we know that C and H go together because they have 2 marks. And again, if we have 2 sets of angles equal, we know our third one are equal. So angle A equal angle F because of your third angle theorem. So we're good as far as angles. So our angles worked for both of them. And now we need to do it for sides. Do we have 3 sets of sides that are congruent? So we've got 1 mark here, we've got 2 marks there, and 3 marks there. I'm not going to bother labeling it because I think it's kind of redundant. I'm going to say yes, they're marked. And so then because of that, then it's going to be a yes answer. Because if we have 3 sets of angles that work and 3 sets of sides that work, then everything works. Now later on, like in lesson 4.2, we're going to talk about side, 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 for example. And that's going to be a shortcut. Like if you have 3 sets of sides that are congruent, then the triangle is congruent. But at this point, we have to use our definition of congruent triangles. And so we have to have 6 pieces of information. We have to have 3 sets of sides and 3 sets of angles. Any questions about that? Okay, number 12. This one's a proof, and it says AD and BE bisect each other. And they also have this other part, which is given. So bisect is our key word. If you remember what we did before, sometimes on the proofs, the very next thing would be definition of bisect. And let's see if that actually makes sense. Well, if AD and BE bisect each other, that means this line cuts this in half, where those are equal. And the BE is bisecting AD, and so that means these are equal. So that's what it means. And over here we have AC equals CD and BC equals CE. So that's going to be right. It's called definition of bisect. Definition of bisect. Now the next one is about ACB, which is this angle in the middle, and DCE, which is this angle in the middle. Those are vertical angles, so you would put vertical angles are congruent. Or it may say vertical angles theorem. You could put either one. So remember, vertical angles are when it makes an X. Okay, so now do we have 3 sets of sides that are equal? There's 1, there's 2, there's 3. So yes, we do. And this one we've got 1, 2. Need to do this one. This would be our third set. And because of that, we would use our third angles theorem. So, like we've said before, if 2 of them in one triangle are equal to 2 in another triangle, then your third angles would be equal. Just as a reminder, if you were given these were parallel instead of equal, then you'd have to use alternate interior. because they would be on opposite sides of the transversal and between the parallel lines. But on this one, since we're giving it to be congruent, we've got to use our third angles theorem. So now that we've proved all 6 things, then we can say definition of congruent triangles. Definition of congruent triangles. I'm just going to put the symbol. If you'd rather write it out, that's fine. Any questions about that proof? Okay, so on number 13, you've got ABC, so that's 1, 2, 3, and JKL, so 1, 2, 3. The A and the J go together, and the B and the K go together, so that means the C and the L go together. Okay, so which of the following must be a correct congruent statement? A to L? No, it's really A to J. This is AB to JL. That'd be no, because it's AB to JK. And on this one, B equal K, yes. So that's going to be our answer. I bubbled it in. I don't know if you can see that or not, so I'm putting yes also. And then the BAC was 2, 1, 3. And so it should have been 2, which is K, and then 1, which is J, and then L. So again, that's a no. So this one's the only correct answer. Okay. Then for number 14, a student says she can use the information in the figure to prove the triangle's congruent. Is she correct? And explain. So the first thing we want to look at is, do you have enough sets of sides equal? You've got these marked and these marked, and you need 3 sets. Where does the third set of sides come from? The third set would come from here. So the third set of sides is reflexive. So that means we're good for having 3 sets of sides. And then as far as angles, we've got this set equal and this set equal. So then your third set of angles is your third angles theorem. So we're good for that also. So that means it's going to be yes. It wants an explain, so don't just put yes. So you'll put that whole thing. So we do have 3 sets of sides, and we do have 3 sets of angles. Number 15, it's relating it to algebra, and we've got x, y, z. So that's your 1, 2, 3, and your 1, 2, 3 here. X goes to the F, and y goes to the E. So that means the Z goes to the D. Okay, so what we know is since the Z goes to the D, we can say 30 equal 2y. And then from there it's easy. We just divide by 2, and so y equal 15. It does say find the values of the variable, so that's one of our answers. The other one is about the 9 inches and the 3x inches. So we'd say 9 equal 3x, and then you divide by 3, and so x equal 3. So those are your two answers for number 15. X equal 3 and y equal 15. Okay, your next one has ABD. So that's 1, 2, 3. And so CDB. That means the A goes to the C, and the B goes to the D. So you might want to just think of it this way, and then this D goes to that B. Alright, so because of that, we know that the 5x is equal to the 75. So then we divide by 5, and x equal 15. So basically we're saying this angle B is equal to this angle D. That's how we know to do it. So just 5x equals 75, so then x is 15. Okay, so now number 17. The algebra part with these. So F corresponds to Q, so that means on this problem that you set them equal. So x plus 24 equal 3x. Don't add it up to 180 because the F and the Q go together. And so then I'm going to subtract x. So I get 24 equal 2x, and then I get x equal 12. So that's my variable answer. Now the directions say find the measures of the given angles or the lengths of the sides, and so we really are not done yet. We need to say angle F equal angle Q, which would be 3 times 12, which is 36, or from 12 plus 24, which is also 36. So this is your final answer right there. Angle F equal angle Q, which is 36. And then on this one, GH are the last two, and RS are the last two, so that means we set them equal. 3x minus 2 equal x plus 6. So subtract x, we get 2x minus 2 equals 6. And add 2, so 2x equal 8. Then divide by 2, and so you get x equal 4. So then don't forget to do this part. 4 plus 6 is 10. So RS equal GH. This is a G, not a 6. And that equals 10. So if you want to think of it worked out, 3 times 4 minus 2. 12 minus 2 is 10. And then the 4 plus 6 is 10. So this one's your answer right there.